Hi, this is Yu Zhang, and this is my recording for assignment 1 of CISC 701. So, first a rerunning of listing 1.1, and this is the code of the listing 1.1. And basically, it's doing the printing of the hello world from CPU and then try to do it from GPU. And when we do it from GPU, we do it 10 times in a row. So we are going to allocate 10 threads from GPU. After that, there's a cleanup of the resource and region 0. And okay, so I have already compiled it. Let me just run it. And this is the result of the execution. We have the hello world printing from CPU and 10 consecutive hello world from GPU printed by this method, this GPU method. Let me see. Here are the exercise. The first exercise is referred to figure 1.5, illustrate the following patterns of data partition. So let me first go to 1.5. For the what are the ones? The first one, the block partition along the x direction of to the data. So basically, with block partition, we're talking about this one. And if we have data, my understanding is we can use this schema to divide the data into several blocks. For example, if we're dealing with a matrix, we can do several row and several column. For example, if we have a 10 by 10 matrix, we can do the first 4 row, first the 4 columns as the first, well, first the 5 row, sorry, first the 5 row, first the 5 column as the first block. Then the first 5 row, the column 6 to 10 as the second block. Similarly, we can using this partition schema to perfectly align with the matrix data partitioning. And about cyclic partitioning along Y direction, cyclic partitioning around Z direction for 3D data. For these two scenarios, since it is cyclic partitioning, basically what we're doing is we're going to assign a fixed amount of data to each partition, and basically the data is not going to be singly dependent on the size of our overall data size. Is more likely to be constrained by the capacity of the GPU. And in that scenario, we're going to give each block of the data to GPU for one computation. And once we have resource available, we're going to give the resource extra data, and each block of the data are going to be allocated, assigned to the GPU in a cyclic pattern, in a cyclic manner. So that's my understanding of these two scenarios. But to be honest, I don't really know how I could describe in particular, what is the influence of the Y direction, the Z direction. I want to discuss with you guys, with Professor more on this one. About the next question, remove CUDA device reset function from hello world. And let me go to the this. Which one? This is exercise 2. And so basically just simply removing that line of the code. And I have also compiled that one. Let me see, exercise 1.2. And basically what's going to happen is we're seeing hello world from CPU only and no printing of the GPU. So the reason is without cleaning up, the data is not being, the calling of the GPU is not being properly processed. There may be more deeper hardware issue on this one, or maybe data issue, memory issue on this one, causing this kind of behavior. Next question, replace function with the CUDA device synchronize. And there we go. That's the question number 3, replacing that one line of the code with this one. And then let me just run it. Okay, so this time I can say that the GPU calling success again. I see 10 consecutive printing out from the 10 threads. And which means CUDA device synchronize can also do similar stuff to CUDA device reset, but I believe there should be difference between them. Synchronize in the sense of parallel computing is more like giving them clock call to calling them. I want to collect data from all of the threads and combine them and printing them in a way that it can be controlled from the host device, from the host. So this one is giving a command to all of the devices, to all of the threads from GPU, and to collect data. So that can be why we are seeing all of this printing. We are seeing all of this printing out of here. And that's why, but in the first question, if we're in the listing 1, since we're using reset, that is simply cleaning up the resource, and returning the message is a side effect of the cleanup. That's my understanding. There might be deeper reasoning of this one, of course. Number 4, since I was not able to actually get the original compilation with SM20 working, I believe that there's some GPU architecture difference between the one listed in the book and the one from the HPC. So yeah, this one won't really have any difference. I'm actually using this one for the listing 1.1, using this compile command for listing 1.1 anyway. For question 5, let me go to here. I have read from the documentation, and this is the table I collected from the documentation. So basically, CUDA compiler MVCC can not only accept .cu file, which is what I'm doing over here with all of this codes, and it can also recognize C source file, C++ source file, and some other ones. The next 3 I'm not very familiar with, but apparently this compiler can recognize them. And then the next we have some intermediate object file, library file, resource file, and a shared resource file from C++ program that can also be recognized by this compiler MVCC. Okay. The next one, number 6, we want to see if how we could print each of the thread ID out from each of the device. So let me go back to over here. That's number 6. Well, the change is fairly simple. We just need to put in the thread, print out the X of the current thread over here. That will do. That will be able to recognize the individual ID of each of the thread and print them out. So this one is actually a very nice feature of the GPU thread, and this one can actually give us a great index, a great entry point of how to manipulate different data in different kind of manners, giving them some simple logics on how we can process data based on the current thread ID. Let me run it. So let's say that's number 6. And yeah, as we can see, we have all of the printing from different thread over here, thread 0 to thread 9. That's because each of the printing is coming from one individual thread from the GPU device. So this is my assignment 1 recording. Thank you very much.